All right, guys. I'm going to start. We're actually hopefully be able to knock the whole thing out. Our next video here will be on the digestive system. Real quick before I get going, if you hear a sound like water running, it is water running. I'm in my storage room because I'm trying to hide from my children, as always. But my sump pump is draining water, so we got a lot of rain over the weekend, so it's just working overtime. I'm not peeing or anything like that, but it might sound like it. So, okay, let's get going with our lecture on digestion. Okay, so as I told you guys at the beginning of the last video, this lecture on the digestive system is not a super long video or lecture. It's only 12 slides, but it is going to cover a lot of organs. So for that reason, there will be 40 questions that I pull from this on exam number 7, and then the 20 from the respiratory. So exam 7 is 60 questions. Okay, without further ado, let's get going. So organs of the digestive system, there's kind of 2 major categories. Those that form a tube going all the way through the thoracic abdominal pelvic cavities. We call this tube the gastrointestinal tract, GI tract. We've referenced that several times this semester. It's also known as the alimentary canal. Rarely, if ever, will you hear me call it anything but just GI tract. And this includes stuff all the way from the mouth to the anus, which includes your mouth, your pharynx, which we talked about the pharynx last time in our respiratory lecture, your esophagus, your stomach, small intestine, and your large intestine. So those are the structures that form the tube. The other structures are classified as accessory organs. They don't perform any digestion or absorption, but assist in these processes. This includes your teeth, your tongue, salivary glands, all of those are associated with the mouth. And you've got 3 majors in your abdominal pelvic area: liver, gallbladder, pancreas. And as far as the tract goes, super long, much longer obviously than we are. Tall, 5 to 7 meters or 16.5 to 23 feet in length, which means that it's not just a single straight tube from mouth to anus. It's going to be very zigzagged and coiled, especially when we get into the small intestine. Embryologically, our tract forms from a tube-like structure that develops outpouchings. These outpouchings develop into the attached digestive organs of the pancreas, liver, and gallbladder. Along the way, there are storage sites, excretion sites, detoxifying sites that are going to do their various things. We'll talk about that. As food passes through the lumen, the internal cavity of our GI tract, it's technically still not inside of us. So if you ate something before, if you're eating something right now, that food is traveling into your stomach, and it's sitting in your stomach, and it's being digested. And not until we break that down and absorb it through the walls of our stomach and our intestines does it actually enter our body, which seems kind of weird because it's inside of us. But as far as like truly inside of our body and doing something for us, not until it is passed through the wall and into our blood or lymphatic system. The functions of the digestive system include transportation of food and water, modifying that food and water to make them suitable for absorption and excretion. Okay. As far as what we do to food, first thing we do is we ingest it. That's just a process of eating. Really, that's the last time we have to think about it until it's time to get it out of us on the other side. Okay. To help with moving that food through our tract, we perform propulsion. Movement of food through the GI tract is just what that is. Okay. Through a muscular contraction process called peristalsis. Peristalsis, I always tell students to think of it like squeezing a toothpaste tube. Which there's 2 types or 2 ways to squeeze toothpaste. And you grab the tube from the very bottom end, the side opposite of the cap, and you squeeze it towards the cap. Okay, always pushing it forward and out the cap. That's what peristalsis is. Okay, so it's pushing it forward. Okay, forward only movement is what peristalsis is, and it's due to alternating contractions and relaxations of the smooth muscle that lines the walls of those GI tract organs. And the other way to grab toothpaste and squeeze is just to grab it wherever and then squeeze, which means you're going to have toothpaste going in opposite directions, one out the cap and the other to the opposite end, which is the way that my wife loves to do it, which drives me nuts, but that's not what I'll talk about at this point. That's a form of muscular contraction called segmentation. I'll talk about that here in a second. And to help with propulsion, to help with digestion, we secrete a production and release from a cell or gland of a physiologically active substance. It begins in our mouth with the secretion of saliva, which is mostly water, but it contains enzymes and mucus and stuff, all of which serve a specific role. And we secrete lots and lots of fluids in our digestive tract every day, okay, to help with digestion, which there's actually two forms of digestion, okay? Digestion includes mechanical and chemical forms. Mechanical is a process of physically breaking down food into smaller pieces. It begins when you take your cheeseburger and you bite into it and you chew it up, grind it up, form it into a ball that you swallow, okay? In our stomach, that continues as we mix that stuff up. It's going to just chop it up into smaller pieces, okay? And that's what segmentation also accomplishes, that other form of squeezing the toothpaste, as I was saying, okay? So segmentation, additional churning that occurs in the small intestine through muscular contraction in the intestinal wall, similar to peristalsis, except the rhythmic timing of the muscle contractions forces the food backward rather than forward only. So it shoots it backward, and it really should say and forward to kind of make it more, make a little more sense. Okay, like squeezing that toothpaste tube in the middle, okay, you're going to end up chopping those pieces up into smaller pieces, and the smaller they are, the easier they are to be chemically digested. Chemical digestion is a process of actually chemically breaking down the food into simpler substances, which means we're using enzymes to break chemical bonds. So it's more sophisticated, more, you know, you have to look at it at the very chemical level. So we're talking very, very small atoms, molecules type stuff. But this takes place in your stomach and your small intestines. The whole reason that we ingest food is not because we're hungry. That might be the basic, you know, primal need and primal reason why we eat. But the real purpose that we feed our body is to absorb and give our body the nutrients that it needs. Absorption is the movement of molecules from the tract to adjacent blood and lymphatic vessels, which can be done by passive diffusion, which means that energy is not needed, or active transport, which means that it is. Okay. Now, we don't absorb everything. There's going to be leftover remnants. We all know that when we're done with that food, we have to get rid of it. That process is called defecation. You know, that's the fancy word for them. But that's the process of eliminating those undigested materials through the anus. In our pictures here on the bottom of the page, this is just a representation of all those different organs you can see. Not only are we going to talk about things like the small intestine, but we're going to talk about the parts of it, which includes the duodenum, jejunum, the ileum. We'll talk about all the different segments to your large intestine. Talk about, you know, everything from the mouth all the way down. So it is, you know, very significant amount of stuff we will cover. Over on the right side, this is the abdomen of a cadaver that's been opened up. Basically, ab muscles and skin and whatnot have been removed. So you can see small intestines. You can see how much folding and zigzagging is going on. That's where the majority of that length comes from. What was it, 16 and a half? Yeah, to 23 feet. Okay. Big size liver above that. You can see a little bit of the stomach. You kind of lift the flap here of the liver out of the way to really kind of see the stomach. Many of the organs like the pancreas, which you can see are dotted in here, would be behind the stomach. Okay. We talked about that before. The retroperitoneal organs, pancreas, and some others. So you have to move some others out of the way and move the peritoneum out of the way, which we'll talk about here in just a second. First, let's just talk about the tract itself. As previously stated, it's that complex tube from one end of the body to another. It runs from the lower esophagus to the anal canal. Or I should say, it has the same four-layered wall setup from our lower esophagus to the anal canal. This includes a mucosa on the interior all the way out to the serosa, and each of which has a specific role and is illustrated here at the bottom of the page in our picture. Okay. Let's talk about the mucosa. This is a mucous membrane, hence the name mucosa. Lines the inside of the digestive tract from our mouth to the anus. It consists of three sublayers, the innermost of which is the epithelium, the middle lamina propria, which is connective tissue, And then it has a small, thin layer of muscle called the muscularis mucosae. This is a thin layer of smooth muscle. Functions of the entire layer is to secrete mucus, digestive enzymes, hormones, which are not going to be secreted into the tract, but instead into the bloodstream. Absorption of end products of digestion into the blood, and protection against infectious diseases. And if I zoom down here to the bottom, the three layers are illustrated. The epithelium is this thin layer on the inside lining the lumen. You've got the thick layer, lamina propria. That's where you're going to find glands. You can see those glands are kind of sporadically located throughout. You'll find mucosa-associated lymphoid tissue. Think back to when we talked about the lymphatic system, we learned about MALT, like Peyer's patches, which are found in the small intestine. These are lymphatic structures that just provide extra protection against things that might be in our GI tract, viruses and bacteria and stuff that we don't want. So that's why it says back up here that it protects us against infectious diseases. And these mucosa-associated lymphoid tissues, or MALT, are nodules providing protection against disease. And then on the outside here of the mucosa is that muscularis and the smooth muscle layer. Directly surrounding the mucosa is a submucosa. A submucosa is made up of areolar connective tissue, where you find a lot of blood vessels, lymphatic vessels, lymph nodes, and nerve fibers. So both the mucosa and submucosa are going to have glands. They're going to have blood vessels, for which those substances that are here travel in to be absorbed into the body. Something special associated with the submucosa is what we call the submucosal plexus. This network of nerves, this yellow branching system here surrounding it, is what controls the secretion of those glands from the submucosa. And those glands are not going to be just releasing their substances into the lumen of the stomach all the time. They're only going to be activated in certain situations, like when food is actually in your small intestine or stomach or wherever we're at. And that's what activates these to activate these. And there's another plexus called the myenteric plexus, and that's associated with our third layer, the muscularis. This is named the muscularis because it's a layer of muscle tissue. Now, what type of muscle is dependent upon where you're at in the tract? The mouth and the pharynx, so our mouth and our throat, made up of skeletal muscle, which is important for the act of swallowing, which, if you think back to when we talked about muscle, we learned that skeletal muscle is voluntarily controlled. And that's a process that we consciously are aware of, whether it's a drink that we're swallowing, whether it's food that we're swallowing, where you're consciously, purposely pushing that food from our mouth and into our throat. After that, really, everything's taken care of for us. And that's because everywhere else we're going to have smooth muscle, which your stomach has 3 layers. That's the most amount of smooth muscle that you'll find as far as the tract goes. The rest just have 2, and by the rest I mean the small and large. And between those layers, the muscularis is the second plexus, myenteric plexus, and that's what activates the contraction and relaxation of those muscles. And muscles don't just contract and relax on their own. They need a nerve signal. A nerve signal is going to come by way of these branched nerves. The final layer of the tract is called the serosa, serous membrane lining the outside of the organs. It's composed of areolar connective tissue covered with a layer of simple squamous epithelium called mesothelium. So there's the areolar connective tissue. This would be the epithelium or mesothelium as it's labeled up here. And we also call the serosa a visceral peritoneum because it forms a portion of our peritoneum. Now, the peritoneum is something I was just referencing on the previous page. I was talking about retroperitoneal. Peritoneum we learned about in our very first lecture of the semester is one of those double layered membranes like what surrounds our heart. The pericardium, what surrounds our lungs, is the pleura. See the same thing in our abdominal pelvic area. Now, not all of our organs contain the serosa. Our esophagus does not. Instead, it just contains a single layer of areolar connective tissue called an adventitia. Now, looking at this picture at the bottom, I've kind of pointed out the most important parts. One thing I want to point out is what's labeled here as the mesentery, which is an extension of the serosa that I'll talk about here on the very next page. For that reason, since this is mesentery, I can tell you that this would be the small intestine. Okay. Another reason I could tell you that is because there's only 2 layers of smooth muscle, inner circular and outer longitudinal. If there had been 3, I would know that this would be the large intestine, or excuse me, the stomach. There's other things I won't really get into, but those are reasons that I can tell you, this happens to be the small intestine. Let's talk about the peritoneum a little bit more. This is the largest serous membrane of the body. It consists of a layer of simple squamous epithelium called mesothelium and an underlying layer of areolar connective tissue, what we just talked about on the previous page. It's divided into 2 layers, parietal and visceral. Parietal is what lines the abdominal pelvic cavity. So if we were performing this dissection, what they probably would have done is just made a cut vertically straight down the middle of the body, the belly button, that kind of stuff, all the way down to the groin, and they'd make some horizontal cuts, and then they'd lift those flaps out. Okay? As they lifted those flaps and opened it up, kind of like opening up a jacket, there would be a shiny membrane on the inside of that, kind of like the inner lining of your jacket, and that's what the parietal peritoneum would be, kind of as far as the analogy goes. The visceral peritoneum is what covers some of those organs in the cavity and is that serosa that we just talked about. The space between them, where you find lubricating serous fluid, is called the peritoneal cavity, peritoneal space, where we find a lot of organs, but not all organs. Okay? Some organs lie on the posterior abdominal wall and are covered by the peritoneum only on their anterior surfaces, meaning that they're not located in the peritoneal cavity. Okay? These organs include the kidneys, the ascending and descending large intestine, the duodenum, pancreas, which I was talking about. We call those retroperitoneal. Unlike the pericardium and pleura, pericardium surrounds the heart, pleura surround the lungs. The peritoneum has large folds that weave between the visceral organs, binding them to one another and to the walls of the abdominal cavity. This includes your blood vessels, your lymphatic vessels, and nerves that supply these abdominal organs. And there are 5 major peritoneal folds, one of which I mentioned on the previous page, the mesentery. I'll get to you in a second. Let's talk first about the greater omentum. This is the largest of all the peritoneal folds. It's what this yellow, kind of gross looking like substance is. This is essentially the same picture as what was on the first page. So they show a little bit more of the chest. Notice on the first page, though, we could not see the greater omentum. They would have to have removed that because it just covers those intestines and other organs of the abdominal region, kind of like an apron covers your tummy if you're wearing an apron when you're cooking. It drapes over the transverse colon and the coils of the small intestine like a fatty apron. It is a double sheet that folds back on itself and consists of a considerable amount of adipose tissue. And this can unfortunately greatly expand with weight gain, giving rise to that characteristic beer belly that none of us have. And here's a picture of it. This is the real deal of a cadaver. It's really gross. We dissect the cats. We have to remove that pretty much right out of the way. A lot of people get kind of grossed out by it. All right, the next is the falciform ligament. You can actually see a little bit of it here. This is always associated with your liver. Okay, it's what separates the right lobe and the left lobe of your liver. It runs vertically right down the center of the body. It does not create equal halves to your liver, because most of your liver is over on the right side. The right lobe is quite a bit, about 80%, I believe, of the entire organ, or so, 70% maybe. The left lobe is a lot smaller than that. But it attaches the liver to the anterior abdominal wall and the diaphragm. There's a lesser omentum. This arises at anterior fold in the serosa of the stomach and duodenum, suspends stomach and duodenum from the liver. You lift up on the liver like what's shown here in this picture. That'd be the only way to show it. Okay, and there's the stomach holding to it. Mesentery, I pointed out on the previous page, fan-shaped fold of peritoneum, finding the jejunum and ileum, the small intestine, and the posterior abdominal wall. Mesentery is labeled here in this sagittal section picture. You can see how it's holding those parts of the small intestine to the back wall. Here, where the small intestine has been kind of folded out, you can see the mesentery. Similar to the mesentery is the mesocolon, our last one. This is known as the mesocolon because it's associated with your colon, your large intestine. So it's two separate folds of peritoneum binding the transverse colon and sigmoid colon of the large intestine. All right, now we get to actually start talking about the organs. And like I said, we're going to just move from the top down, starting with your mouth, also known as your oral cavity or buccal cavity. A lot going on with the mouth. Starting the outside with your lips, also known as labia, which are covered externally by skin, internally by mucous membrane. The junction between the skin and mucous membranes is highly sensitive, which makes sense because we're touching stuff with our lips, food and drink, and testing it before we put it into our body, whether it's hot, whether it's cold, that kind of stuff. Lips are very important, not only for eating, but also for forming sounds. Associated with each lip and attaching it to our corresponding gum is a midline fold of mucous membrane known as a labial frenulum. And that's what this little tag is here, associated with your upper lip and your lower lip. If you put your tongue between your teeth and your lips, you can feel that little tag, that little piece of mucous membrane is a inferior labial frenulum. If you're feeling below, above it's the superior labial frenulum. And your cheeks are the lateral boundaries of the oral cavity, continuous to the lips, lined by mucous membrane. Oral vestibule is the space bounded externally by the cheeks and lips, internally by your gums and teeth. So, like if you fill your mouth with air and you blow your cheeks out, fucking your lips so the air doesn't escape. Okay, that space on the outside of the teeth, but inside your mouth, is the oral vestibule. Okay. It's a pretty big space. You think about like right in here in front of your incisors. This is where people put chewing tobacco and that kind of stuff, unless they put it on the sides. Okay. The space extending from the gums and teeth to the fauces being the opening to your throat, is called the oral cavity proper. So this is where your tongue's at. It's behind the teeth, and that's a much larger space. But your tongue occupies that space. And so it's not as large as it really could be with the tongue being in the way. As I mentioned, the fauces is the opening between the oral cavity and the oral pharynx. I actually pointed that out on the previous lecture in our picture of the pharynx. Your hard palate is the roof of your mouth, about the anterior 2/3 of which, of your roof of your mouth, two different sets of bones, two maxillae. Your maxillae is your upper jaws, two palatines. From your hard palate. In the back of your mouth is where the soft palate is. It's called soft palate because it's made up of muscles and assists in swallowing. It's the partition between your mouth and nasopharynx, and those muscles are arranged in an arch structure. It represents about the back third of your roof of your mouth. Two arches actually exist that are associated with your soft palate: a palatoglossal arch and a palatopharyngeal arch. And palatoglossal is the anterior arch, palatopharyngeal arch is the posterior arch. Between the two arches is your palatine tonsils that we've mentioned. You can see those are on both sides. These are the ones, as we mentioned before, can become inflamed and really kind of close down on your fauces, making it difficult to swallow. And that's the set of tonsils that are a lot of times removed when somebody has that issue. Hanging down from your soft palate is called the uvula. I pointed that out in the last lecture as well. This structure is what looks like a punching bag back of your throat, back of your mouth. What it does is it slides back and up, and when we swallow, and prevents food and beverages from going back up and into the nasopharynx. Okay. All right, your final structure I want to talk about on this slide is your tongue. Solid mass of skeletal muscle covered by a mucous membrane. So your tongue is just basically a muscle. Functions to position food during mastication, which is fancy word for chewing, and it helps gather that food into what's called a bolus. A bolus is just a ball food and saliva mixture that we're then going to swallow. And, your tongue's also very important. We talked about this before in forming words. Your extrinsic muscles attached to your tongue connect it to the skull and your neck to help move your tongue side to side and in and out. So those are muscles that are not within the tongue. The muscles within the tongue are called intrinsic muscles. Those originate and insert into connective tissue within the tongue, and they help alter the shape of the tongue for swallowing and speech. So being able to move your tongue around is associated with the extrinsic muscles. Changing the shape of the tongue, I should say, is the intrinsic muscles. Like our lips, there's a fold of mucous membrane associated with your tongue. This is called the lingual frenulum. That's this fold here. That's going to help attach the tongue to the floor of the mouth. Also associated with our tongue are lingual glands. And I've told you this before. Anytime you see the word lingual, it refers to tongue. These are found in the lamina propria of the tongue and secrete both mucus and a watery serous fluid containing an enzyme lingual lipase. Bottoms of these letters got cut off by this picture. Sorry about that. The lingual lipase is the P. Actually helps with digesting fats. So our tongue helps us digest fats, interestingly enough. Structurally, the tongue is made up of three parts: a root, body, and tip. And we've seen that before. We've talked about that before. Back when we learned about the taste buds and that kind of stuff that are found on the surface of the tongue. Okay, very important picture. A lot of things going on here. I pointed out most of them. One thing I did not cover, and I'll talk about it on the next page, are the teeth. Okay, the teeth and gingivae. Gingivae are your gums. Will be discussed here. Okay. Our teeth are embedded in the sockets of both our upper and lower jawbones, so our maxillae upper, and then your singular mandible lower. The sockets in which those are found in are called alveoli, alveolus, singular. We talked about those all the way back when we talked about bones. Each tooth is surrounded by gingivae, or your gums, and our teeth are pretty complicated little boogers. You can see a lot of things going on with them. Got a picture of them, or of one at least here. Performed a sagittal section to see the interior of it. There are three major regions. That's what these brackets over here on the left side of the page are representing: the crown, neck, and the roots. The crown is a portion of the tooth visible outside the gums. So, when we smile, that's what we see. The root is the portion of the tooth embedded in the jaw, kind of like the root of a tree typically is embedded in the earth. And then the region at your gum line where the crown and the root meet is the neck. Okay, let's talk about the parts of your teeth. Covering the outside of your teeth is very hard. In fact, it's the hardest material on the body, enamel. It's non-living material, and its hardness comes from calcium compounds like what we have in our bones, but it's actually stronger than bone. Like bone is actually dentin, which is calcified tissue. Like bone composes the bulk of the tooth, represented here in the picture with this orange. On the outside, the white is the enamel. Notice that in our picture we show that the dentin doesn't actually cover the interior of the tooth. In fact, our teeth are actually hollow structures. That cavity within your teeth is known as a pulp cavity. This is a central cavity inside the tooth where we find blood vessels, nerves, and connective tissue. The fluid and whatnot that's found here is called pulp, and that's why it's called a pulp cavity. Let's see, what else? Oh, the cavity extends down into the root of the tooth. This is called the root canal. You've probably heard of the procedure called a root canal. This is where a person's tooth has rotted out so bad that it's rotten down in here. So what they do is they drill down into the root canal. Sounds absolutely terrible, but it's a fairly common procedure. And so they clean all that out and get rid of the infection. At the very interior of your root canal, there's a little opening called an apical foramen. In this case, there are two because there's kind of two roots. Not all teeth have the double root situation here. This is a molar. It does. But the apical foramen is the entrance for nerves and blood vessels, or exit pathway for blood vessels, if you're talking about a vein. So those are associated with the root canal. Okay. Other things I want to talk about: cementum, periodontal ligament. We've actually mentioned before. Cementum begins with the word cement, which is a hard, substance we make foundations out of, patios out of, that kind of stuff. But it's a bone-like substance covering the root and functions to bind the tooth to the periodontal ligaments. The periodontal ligament is the actual structure that connects the tooth to the socket, the bone, the alveolar bone, as it's labeled here in our picture. Okay, that covers the parts of a basic tooth. Now, one thing I want to talk about is the fact that humans are described as having differentiated teeth. Differentiated teeth means that we have different types of teeth. It's not like we have one type of tooth inside our mouth. We've got multiple types, each of which it has a specific shape, which depicts, or not depicts, but is built for function. Okay. And front, the teeth that you use to bite into food are your incisors. Okay. Think of these like a chisel, kind of like a flathead screwdriver. There are 4 uppers, 4 lowers, so there's 8 total. The 2 that are in the front, we describe those as like buck teeth, are central. To the sides of those are your lateral incisors. And those were shown on the previous page, and they're also shown over here. This is an adult set of teeth. This is, what we describe as like baby teeth. I don't have nearly as many baby teeth as we do as when we are an adult. Not that I'm going to ask you to know all this stuff, but there you go. Okay, so what I always tell students to do is you use your tongue, kind of just follow along with me. So move from your incisors to your canines. These are also known as cuspids. We have 1 on each side, upper and lower, of your incisors. So there's 2 uppers, 2 lowers. These kind of come to a point, kind of like an ice pick, if you want to think of it that way. And these are great at ripping and tearing food. They're known as canines because they are what animals that are classified as canine have. So like dogs and wolves. If you're thinking of like Dracula, these would be the teeth that come to a point that allow him to bite into your neck. Moving on from those, our teeth are going to start to kind of flatten out a little bit more. In this area, not quite completely flat, are your premolars or your bicuspids. There's 8 total, so 4 uppers, 2 on each side, and then 4 lowers, 2 on each side. These are responsible for chewing and grinding your food. If you think about when you bite into food, you bite it, and then you don't use your front teeth anymore really after that to chew that food up. You move it to the sides. Okay. There are described as having 1st and 2nd premolars. They kind of come to a point, but they're a little bit more flattened. But your most flattened teeth, and that's what we see here, are your molars. There are 8 total of these as well. Good for chewing and grinding food as well. And when I say there's 8 total, that's really not true because there's a 3rd set. Okay? These are typically described as your wisdom teeth, but they don't develop in all people. I always like to joke that people that don't have them are just superhumans, which I happen to be. Genetically, I guess for whatever reason, my dad passed this on to me. He didn't have any either, but I was born completely without any wisdom teeth, so I never had to have that procedure done that many of you have done or have had done. What's also weird about teeth, some people have all their wisdom, some don't have all of them, some have 1, 2, maybe 3. Teeth are weird. Sometimes people have extra teeth when they're not supposed to, and those get pulled. It's kind of a person by person basis, but typically there are 12 total molars when you count the third molars over your wisdoms, but not everybody. As far as naming teeth, we just talked about that, but they also use a system as like, dentists use these, they number them, starting with the uppers and then far back left all the way around, and then they go through and count them the opposite direction in your bottom teeth. Not something I would ask you to know. What's cool about the pictures here is they show when they kind of come in, and then as far as baby teeth go, and then your adult, your secondary teeth or permanent teeth, as we call them, is what's shown over there on the right. I'm not going to ask you to know these two pictures on the right. Definitely would recommend you know in this picture, and then be able to identify them here on this previous page. All right, moving on. Almost done talking about the mouth. One last set of structures to talk about. Your salivary glands. These are glands that release secretion called saliva into your oral cavity, saliva or spit as we call it. It's predominantly water, almost completely water, 99%. Rest of which is going to be enzymes, salivary amylase, which helps us digest carbohydrates. Lingual lipase, as I mentioned, helps us digest fats. There's lysozyme, which is an enzyme that kills bacteria. There's proteins, antibodies, and various ions. So there's a lot of stuff. Mostly, though, it's water. Mucous membranes of our mouth and tongue contain many salivary glands, but these are very small, opened directly or indirectly via short ducts to the oral cavity. The ones associated with your lips are called labials. The ones associated with the inner surface of your cheeks are the buccals. On the upper portion of your mouth, the hard palate, soft palate, that's the palatal glands, and then the lymph glands, as we mentioned, are located within the tongue. They only contribute a very small amount of your saliva. Most of your saliva comes by way of what we call the major salivary glands, which are found outside the oral mucosa, so outside that inner lining of your mouth, lips, and that kind of stuff. So they have to have a long duct or something, not necessarily a long duct, but a longer duct to carry their secretions into the lumen of the oral cavity. And there are 3 pairs. So there's 6 total, 1 on each side for each of these. First of which is the largest, your parotid gland, which actually translates to be near the ear. It's in your cheeks, just underneath your skin, between it and this masseter muscle that we learned about earlier in the semester. This has a long duct that delivers the saliva between your upper molars, as you can see there. The next pair are the submandibulars. Okay, this is kind of a funky image. Basically, kind of the jaw area right in here where I'm grabbing, it's just been removed, so we can see this and more so the next one. But kind of along your jawline there, underneath there is where you'd find the submandibular glands, and they deliver their saliva on both sides of the lingual frenulum. If I go back to this picture, there are 2 little openings, and they're actually labeled the opening of the duct of the submandibular glands. These are the ones that tend to be what cause gleeking. If you don't know what gleeking is, I had a semester where no students had ever experienced that or knew what that was. Like if you yawn, sometimes saliva will shoot out of there, like you're that dinosaur from Jurassic Park. It's typically where that seems to happen for whatever reason. It's not something you can control and do on purpose. This is all involuntarily done, but sometimes it happens. Your sublingual glands, remember lingual refers to tongue. These are located just underneath of your tongue, in front of the submandibular glands, and they deliver their secretion via ducts. You can see several of them in the picture beneath the tongue. Here, this is a cadaver. I included it. What they have not done is remove the jawline, so you can't see the sublinguals. But you can see the good size to the parotid over here on their right side of the face. Submandibular is visible as well. So that's kind of cool. Like I said, I always try to include the real deal whenever I can. Okay, finally, we get to move on from the mouth. Talk about the pharynx, something we just have talked about in our previous lecture. We'll also talk about the esophagus in this lecture as well. both of which are involved with the act of swallowing. So that's why I've gone ahead and thrown them in on the same page, along with your mouth, which also helps with swallowing. Fancy word for swallowing is, is deglutition, where we move a mass of food called a bolus from our mouth to the esophagus, and really should really say into the stomach. Between our mouth and the esophagus is a pharynx, that funnel-shaped tube extending from our internal nares to the esophagus posteriorly to the larynx anteriorly. Passes food to the esophagus through only 2 of the 3 segments, and that's because we aren't ingesting food and beverages, hopefully anyway, through our nose, so the nasopharynx is not involved. Your pharynx is composed of skeletal muscle lined by a mucous membrane. We talked about that last time, so we'll just kind of move on from it. Your esophagus, brand new organ, did mention it last time, but here we get to learn about it. Collapsible muscular mucosal lined tube, extends from the pharynx to the stomach, about 25 centimeters to 10 inches in length, about 4 centimeters or 1.5 inches in diameter. Runs posterior to the trachea and the heart, and the key function of it is to push food towards the stomach via muscular contractions, known as peristalsis. Remember, that's the squeezing of the toothpaste tube, the way that I like to do it, the back towards the front. And this is the major means in which we push that food into our stomach. Well, gravity does play a role, but gravity is not, the only thing required. We could actually stand on our heads and drink and eat and swallow, and that food is still going to make its way into our stomach. It's not really recommended, but it is possible to do. At each end of your esophagus, there is a circular ring of muscle called a sphincter that regulates the movement of that food into for the upper and then out of for the lower esophageal sphincter. Okay. The upper controls the movement into, as I mentioned. The lower is also known as your cardiac sphincter. It's what controls the food movement of that food into the stomach. Okay. It's called the cardiac sphincter because this is kind of located kind of almost right in behind your heart, a little bit below where your heart would be, but your heart, remember, sits kind of right in here. You've probably heard the term. We all have probably experienced this as well. Heartburn. Heartburn is anatomically known as gastroesophageal reflux disease, where contents of the stomach actually can leak back up into the esophagus. Very detrimental because our stomach is loaded up with hydrochloric acid and other things that can be very hard on that inner lining mucosa of your esophagus. And this condition is a result of a failure of that lower esophageal sphincter. We call it heartburn because it might feel like your heart is actually burning when in all actuality it has nothing to do with your heart, but it does involve that cardiac sphincter. Ways to prevent it, don't lay down right after you eat. Take Tums, obviously, if you really experience it. Try to drink fluids. Chew gum, actually, is supposed to really be helpful because of the saliva that you produce that you swallow. Helps, kind of push that stuff down and keep your inner lining soaked. Back when we learned about the diaphragm, we learned that several things: your aorta, your inferior vena cava. We also talked about the time esophagus pierced through it. The opening in that diaphragm for the esophagus is called the esophageal hiatus. As I mentioned earlier, this process of swallowing is called deglutition. It's a complex process requiring coordinated rapid movements. Actually, is a 3-step process. An oral stage, which is the voluntary stage. The rest is involuntary, is the pharyngeal and the esophageal. So we only have to have conscious control of one of those 3 processes. And this is the last time we really think about that food until it's time to get it out of our body. The oral stage is where we move that food from our mouth to the oral pharynx. It involves in forming a bolus in the middle of our tongue, pressing it up against the palate, and then the food being moved into the oral pharynx. From there, the pharyngeal stage is where the food moves from the esophagus or into the esophagus, involuntarily controlled. For this to occur, the esophagus or the mouth, the nasopharynx, and larynx must be blocked, and a combination of contraction and gravity help to perform this. Final stage, this is the longest stage. It's where that bolus moves down into the stomach through the esophagus. Contractions and gravity help move this bolus down into the stomach to prevent aspiration or choking, moving that food or drink into your lungs and up into your nasopharynx. Several things take place. That uvula, which hangs down from the oral cavity, as I mentioned, moves up and closes up the nasopharynx. The trap door that we talked about last time, the epiglottis, moves back and down to close open your trachea. Your larynx actually helps pull forward under protection of your tongue as well. Food slides down over the epiglottis and the esophagus, and your vocal cords that are in your larynx help close it to block the airway some more. Since we're closing off your airway, we can't breathe while we swallow, but it's not for a long period of time. It's only about 2 seconds. Okay, moving on to the stomach. This is a portion of your digestive tube that can dilate or expand tremendously. It's going to be able to do that because it's got these accordion-like folds on the inside we call rugae, and which you can see here. This is where you can really see them. This is a cadaver where basically the whole front of the stomach has been removed. I imagine everybody knows what an accordion is. It's that instrument that makes kind of weird noises. You open it up, and push it back together. These folds, called rugae, are specialized structures of the mucosa layer of the stomach. The stomach itself is located in the upper part of the abdominal cavity near the liver and diaphragm, and it functions to mix saliva, food, and gastric juice to form what we call chyme. I'm going to try to avoid calling it food at this point because really it's not food anymore. It's this mixture of food plus a lot of other stuff. Our stomach also serves as a reservoir for food before being released in the small intestine. We secrete gastric juice to aid in digestion, and our stomach actually even secretes hormones like gastrin into your blood. And another very important thing our stomach does is it kills bacteria because of the hydrochloric acid that it produces. The mucosa of your stomach also contains specialized structures called gastric pits, which are shown here in this illustration. This is showing you the 4 layers we talked about earlier in the lecture, inner lining being mucosa all the way out to the serosa. Notice there are depressions within mucosa. Each of those depressions is called a gastric pit. You all know what a pit is, I would imagine, kind of crevice depression. This gastric pit is lined with several different types of cells. That's what I'm going to talk about in just a second. So actually, let's just go ahead and talk about them right now. There's 2 types of cells, exocrine and endocrine. Exocrine means that they're going to secrete their substances from the cell and into the lumen of the stomach. Okay? So excrete that substance out into the inner part of your stomach. The first type are, I'll just kind of talk about these together, the mucus cells of the stomach. There's 2 types, mucus surface cells, mucus neck cells. The difference is just where they're located within the pit. These are closer to the surface. These are down in the neck of the pit. Okay? But they both produce mucus, which is super, super important in our stomach. Okay? The actual types of cells are goblet cells. We secrete a really thick glycoprotein mucus into our stomach that helps protect the inner lining of our stomach from the action of those acid and digestive enzymes that we also produce and release into the stomach. Okay. If you ever dealt in like a chemistry class with hydrochloric acid, very dangerous. You can't even like breathe its contents. Like you never want to take a smell of it. It's going to burn you. You don't want to get it on your skin. It's going to burn you. You get it anywhere in your body other than your stomach, it's really going to be pretty hard on you. And the reason our stomach is not going to have just ulcers burned into it all the time is because of the very thick mucus that we produce. Now, speaking of that mucus, it's produced by what we call parietal or oxyntic cells. These are scattered along the neck and the lower walls of the ducts. They secrete that hydrochloric acid, hydrogen ion, and then intrinsic factor, which is a chemical that helps with absorbing vitamin B12. Other cells include chief or zymogenic cells. In the lower walls of the duct, they secrete pepsinogen, which is an enzyme that helps with digesting protein, gastric lipase, which helps with digesting fats. You can see those are all labeled here in our picture. They all have a unique shape, not something I'm going to talk too much about. And the other type of cells associated with our gastric pits are the endocrine glands, or endocrine cells, or G cells, as they're labeled down there at the bottom. Secrete various hormones. Now, the key with these, they're not going to be dumped into the lumen of the stomach, but instead the hormones are going to be dumped into the bloodstream. And the function of gastrin, it's a hormone that actually just kind of activates the rest of the cells of the stomach to increase their output. So that's stuff associated with mucosa of the stomach. I'm not going to talk much about the submucosa of the stomach, but I do want to talk about the muscularis. Again, remember, the muscularis of the stomach is going to contain 3 layers of smooth muscle, which is unique compared to the rest of the tract. There's 3 layers: an oblique, a circular, and a longitudinal layer. And those are labeled here in our picture here on the left side of the page. The oblique layer is the inner layer. It kind of runs at an angle between the circular layer, which runs horizontally like this, and the longitudinal that runs like this. So you've got one that runs up down, side to side, and then kind of at an angle between those. So it enables the stomach to really kind of squeeze and push stuff around, and basically we're just, doing a lot of mixing in our stomach and chopping that food up through segmentation. In our picture here on the left side of the page and down here at the bottom, we can see, and this picture shows it in caps, the major parts of the stomach. And first part is bracketed off right here, is called the cardia. This is the collar-like region at the junction of the esophagus. Cardia is where that cardiac sphincter is located. Remember, the cardiac sphincter, same thing as the lower esophageal sphincter. Okay. Above, and it's kind of weird that it is, that cardia is the fundus. This is a large portion to the left and above the opening of the esophagus into the stomach. The majority of your stomach is the body, and it's the central portion. Okay, it's the widest, and then it starts to taper towards the duodenum. Where it tapers, you can see that here is the pylorus, and this is what just connects the stomach to the small intestine. And there's 2 parts, the first of which is called the pyloric antrum, which connects to the body, and then the pyloric canal, which really starts to taper. And pyloric canal, at the end of it, is where you find the pyloric sphincter. Pyloric sphincter is the sphincter that regulates the movement of the chyme, I won't call it food, from the stomach and into your small intestine. Now, in order to empty your stomach, we do it at very, very small amounts at a time. One of my biggest pet peeves is when people, eat something and then they have to go to the bathroom and they're like, man, that ran right through me. No, it's not even out of your stomach for like 2-6 hours, depending on what you ate. Several hours, food sits in your stomach, and before it's even, moved completely out and into your duodenum. And we don't just dump it all at once, we dump it in small increments. So don't be one of those people that thinks you digest your food in 30 minutes, because that's not even close to being the case. Now, if we were continuing on the tract, we would move in to talk about the small intestine next. But you'll notice our next organ I want to talk about is the pancreas. Okay, pancreas is a accessory organ. We're going to talk about 2 more on the next page, your liver and your gallbladder. And there was a reason for which I'm going to do that, and I'll get into that here in a second. But pancreas is an organ we've talked about before. Back when we learned about the endocrine system, we learned that there were cells that make it up called pancreatic islets, or islets of Langerhans, about 1% of the cells, which secrete hormones like glucagon, insulin, and I'm not going to talk about those. What I do want to talk about is the other 99% of the cells that help with digestion. And before I talk about those cells, let's just talk about the pancreas itself as a whole structure. It's retroperitoneal, as we mentioned. It lies greater or posterior to the greater curvature of the stomach. about 12 inches in length, tapering from right to left. 3 major regions make it up. The head, which lies to the right, nestle on the duodenal sweep. That would be like right in here, and as the duodenum comes back down this way. Actually, I can just show you right here on this picture. But duodenal head right there. The body is the middle portion, and the tail is the tapering portion, which kind of points right into your spleen. As far as the word pancreas actually means all flesh because of its ability to digest virtually all proteins. Secretions of the pancreas are called pancreatic juice, produced in clusters of exocrine cells called acini. Acini is plural, acinur is singular, center cells, how you'd say that, which represent 99% of the cells of the pancreas. They create the pancreatic juice, which is then going to be funneled and drained into a series of ducts. And there are 2 major ducts that ultimately are formed from those smaller ducts, what we call the pancreatic duct and the accessory duct. And pancreatic duct is this big duct right here that continues on, and notice where it goes, into the small intestine, into the duodenum. Here's the accessory duct. I'll zoom out a little bit better, you can see it. So here's the pancreatic duct, here's the accessory duct. They also have different names, ductus santorini for accessory. The pancreatic duct is also known as ductum bursi. Okay. Your pancreatic duct is the larger of the 2. Most people, it actually joins another duct, what we call the common bile duct, which is a duct that is coming down from the liver and gallbladder. And they, you can see here where they're joining together. They form a structure, it's called the hepatopancreatic ampulla, just as the duct that's formed from the union of those. Okay. They do is collectively dump their secretions of bile from the common bile duct, pancreatic juice from the pancreatic duct, into your small intestine at what we call the major duodenal papilla. This lies about 10 centimeters or 4 inches inferior to the pyloric sphincter, what we just talked about on the previous page. The passage of this pancreatic juice from the pancreas and bile from the liver and gallbladder is regulated by a massive smooth muscle surrounding the ampulla. We call this the sphincter of the hepatopancreatic ampulla, just labeled right there, also known as the sphincter of Oddi, but not something I'm asking you to know. What this picture is just right here, this box right here, which is zoomed in so you can see things a little bit better. The accessory duct leads from the pancreas. It empties into the duodenum about 2.5 centimeters, right about an inch superior to the hepatopancreatic ampulla. So right in here, about an inch above that. I already talked about this bullet. Pancreas itself, very richly supplied with arteries and veins, served by branches from the hepatic artery, gastroduodenal, pancreatic duodenal, superior mesenteric, and splenic arteries. And the major nerves innervating it are the vagus nerves, providing circulation. Here's a picture from a cadaver where you can see that definite big size pancreatic duct. Kind of hard to see some of the other stuff like the accessory duct. But we can see actually there's a little opening that major duodenal papilla where it's opening up. There's your small intestine. Common bile duct you can see is coming down. You kind of don't really see where they merge together, but they do. And as I mentioned, we can't really see the accessory duct, but it would be there, I promise. Now, what we're going to do on the next page is talk about the liver and the gallbladder and these other ducts, which includes that common bile duct that I've been mentioning. We'll actually have that picture again on this page to show the parts of the liver and gallbladder. All right, liver, this is your largest gland or organ in the body, weighs approximately 1.5 kilos or 3 pounds, and it performs many things. It aids digestion by producing bile. Bile is the chemical that emulsifies fats, basically fat in our stomach, kind of just like clumps together. It's all chemical stuff that I won't get into, but it's really hard to just digest a big fat globule. And so what we do is we break those things down by way of bile. And now the liver is not where that takes place, it's the small intestine where that bile ends up going. Other than producing bile, your liver performs metabolism on your carbohydrates, your lipids, your proteins, detoxification of drugs and alcohol and other chemicals in the body. Stores vitamins and minerals, performs phagocytosis. There are macrophages in there that can chew up and spit out and break down things. Stores vitamins, excretes bilirubin, which is a product of the breakdown of hemoglobin, and activates vitamin D that we get from the sun, and processes drugs and hormones. As I mentioned earlier, there are two lobes that make up the liver, two principal lobes anyway. Left lobe, which is about a 6. Right lobe is about 5'6". The right lobe is so big you can actually break it down into an inferior quadrate lobe and a posterior caudate lobe, which I don't have a picture to really show those off, but I promise you they're there. Between the two lobes is that fold of the peritoneum known as the falciform ligament that I pointed out several slides ago now. Breaking your liver down into smaller parts, we've seen this with several other organs. The functional units or anatomical units of the liver are called hepatic lobules. Here's what a singular hepatic lobule looks like. And then we zoom in a little bit of that here in this picture on the right. Within each lobule, there are hepatocytes, which are the major functional cells of the liver, arranged in layers that radiate out from a central vein. Think of them like a tree ring situation. Central veins at the center, that's the name. And then like rings on a tree trunk, there are the hepatocytes circulating out from around it. And notice that the central vein has connections pushing outward. It looks like a sun to me. And I'll talk about those here in just a second. One of the major functions of those hepatocytes is to secrete the bile liquid that aids in the digestion of fats that I've mentioned. Between the rows of hepatocytes are those hepatic sinusoids, highly permeable blood capillaries that receive oxygenated blood from the hepatic artery and nutrient-rich deoxygenated blood from the hepatic portal vein. And that sentence says a lot. If you think back to when we talked about blood vessels in our last unit, we learned about the hepatic portal vein, which was the vein that carries blood that's already gone through things like your small intestine and your stomach directly to the liver before traveling back to your heart. So that's going to be the blood that's carrying what we call nutrient-rich blood. And your liver also just receives oxygenated blood by a hepatic artery. And so there's kind of two major types of blood that flow into your liver. They flow through it, oxygenated and nutrient-rich. The sinusoids are these radiating out sections that kind of create the sun that I was mentioning. If I zoom in here, we can see where they're going. Notice the direction and the arrows coming from our branch of the hepatic artery and the branch of the hepatic portal vein. And what's coming into and towards the central vein, where the central veins are going to then carry it away from the liver, eventually into the hepatic, the hepatic vein, which then drains into the inferior vena cava. We also see in this picture what we call bile canaliculi. These are small ducts between the hepatocytes that collect the bile produced by those hepatocytes. From there, the bile passes into bioductules and then into bile ducts. Those are basically different names for a tube system, which those bile ducts emerge and eventually form our larger right and left hepatic ducts. So we get bigger and bigger, eventually forming a right hepatic duct, a left hepatic duct. Right hepatic's associated with the left or right lobe, left is associated with the left. Simple as that. Okay. Those then merge, forming a common hepatic duct. Okay. Hepatic always refers to liver. Okay. The common hepatic duct is going to carry that bile down towards your pancreas and small intestine. Okay. There's another duct located right in there called the cystic duct. Anytime you see cystic, that's going to refer to your gallbladder. Let's talk about the gallbladder now. This is the pear-shaped sac located in a depression on the posterior surface of your liver, about 7 centimeters, 10 centimeters at the max, 3 to 4 inches in length. There's kind of 3 major parts to it: a neck, body, and fundus. The broad fundus projects inferiorly beyond the inferior border of the liver. The body is the central portion, the neck is the tapered portion. And, in order to see it, really, a lot of times you have to kind of lift up on the liver because it's kind of tucked in behind it. You can just see the very inferior portion of it here in our cadaver liver. Okay. But here's where you see where it will be located. The function of your gallbladder is to store and concentrate bile that's produced by liver until it's needed in your small intestine. The gallbladder does not produce bile. It just stores it. So some of that bile comes down and then uses the cystic duct to get into the gallbladder. Okay? When time is right, the gallbladder can contract and push that bile back out into the cystic duct and then down into the common bile duct. Okay? The common bile duct is formed by the union of the common hepatic duct from the liver and the cystic duct from your gallbladder, and that's the duct here that we talked about on the previous page, that then joins eventually your pancreatic duct from the pancreas, forming that hepatopancreatic ampulla that we talked about. And here's kind of a flow chart, I guess pun intended there, showing you the way that the fluids flow from the different organs, from here the liver, gallbladder here, pancreas here, all eventually reaching the duodenum. Okay. So the reason I wanted to talk about these accessory organs before we talked about the small intestines, because they're producing substances that are going to the duodenum, the small intestine. So now we get back on track, and that was a pun intended. Okay, talking about the small intestine, or second to last of the organs, but the longest of our organs. It's known as the small intestine, not because of its length, but because of its width. It's about 2.5 centimeters, right at an inch in diameter, but it's about 10 feet in length. So it's over half of the entire length of the tract and is the main site of absorption in the digestive tract. And once again, remember, the whole reason that we eat food is so that we can bring those nutrients into the body, and that's what absorption is. It also functions in mechanical digestion through segmentation, peristalsis. A lot of chemical digestion takes place here via enzymes, and then, as I mentioned, absorption of nutrients. Since it's so long, there are 3 divisions making it up. We just talked about the duodenum. Now, I pronounce it that way. I've had instructors in my schooling called it duodenum. I've also heard it called the duodenum. But this is the shortest region. It runs from that pyloric sphincter of the stomach to what's called the ligament of Treitz. Receives that chyme from the stomach through the pyloric sphincter. Has a C shape, is only about 10 inches in length. The jejunum runs from the ligament of Treitz to the ileum, makes up about 3 feet of the 10 feet. And then the ileum is the final and longest region, runs from the mid-small bowel to the ileocecal sphincter or valve, which is the sphincter that's going to control the movement of that chyme out of the small intestine and into the large intestine. Talk a little bit more about that on the next page where we can actually see a picture of it. Ileum itself represents about 6 feet of the 17 feet, or excuse me, the 10 feet, not 17, 6 feet out of the 10 feet. So about 60% of your small intestine is the ileum. Since it's super long, it's really going to have a lot of surface area available for digestion and absorption, but to increase that surface area, point of contact between the food, the chyme, and the wall of the tract, there are 3 extra features that I want to talk about. And these are circular folds or plicae, which are really visible here on our picture on the right side of the page. You can see it's folded, kind of like the small intestine, but not so much like the rugae that allowed for expansion. Here's a really good picture of them. And these are from cadavers, so you can see this is a real deal. They're going to just project outward about 10 millimeters in length, just to increase the amount of contact that chyme has with the wall of the tract. Now, extending off of those are villi. These are finger-like projections of the mucosa, about 0.5 to 1 millimeter in length. So very, very small. And that's what we're showing right here with this picture. Here are several of them. You can see there are projections of mucosa. On the inside of each of those is an arteriole, a venule, capillaries connecting them, which are the routes for absorption of many nutrients when we absorb water and carbohydrates and proteins. They're going to jump into the blood right in here through the wall and into the blood. And also, we find what we call a lacteal, which we talked about lacteals back when we talked about the lymphatic system, when we learned that they are a specialized form of lymphatic capillary that allows for the absorption of fats. Each villi contains arterial venule, a blood capillary network, and a lacteal lymphatic capillary. Nutrients absorbed by the epithelial cells covering the villus pass through the wall of a capillary or a lacteal to enter the blood or lymph, respectively. The outer epithelial layer, which is what faces the lumen, includes the following cell types. They're shown here in our picture on the right side. And there are the cells right here. First, they're called absorptive cells, which are the ones that do the absorbing. But they also digest because they release enzymes. Goblet cells, like goblet cells elsewhere in the body, secrete mucus, protecting the epithelial layer from digestion. Pannate cells secrete lysozyme, which helps kill bacteria. And then enteroendocrine cells that secrete hormones, not into the lumen, but into the blood vessels that penetrate the villi. If I zoom in at this absorptive cell, notice here that it's showing that it has what we call microvilli. Thinking back to the very beginning of the semester, we learned that microvilli were little finger-like extensions that project off of cells, specifically the apical or free surface, which is the surface that faces the lumen of the small intestine in this case, which increases the surface area. So what we have are folds on the interior of the small intestine, and those folds have little finger-like extensions, which here's the folds. Here are the extensions, the villi, and the cells that line those, not all of them, but some of them have microvilli. So it's like folds on folds on folds, extensions of extensions that just increase the bejesus out of the surface area of the small intestine. We talked about this early in the semester, but microvilli, if you have a whole bunch of them, a bunch of cells that have them, creates what we call a brush border. We have brush border in the small intestine and in our kidneys that we'll talk about in our next lecture. That was all associated with the mucosa of the small intestine, and that leaves us with other layers, submucosa, muscularis, etc. And so some of these things I'll talk about. Intestinal glands or crypts of Lieberkühn secrete intestinal juice located in mucosa. We've also got duodenal or Brunner's glands found in submucosa, secreting alkaline mucus, which helps neutralize gastric acid in the chyme. And then the lamina propria of the mucosa contains abundance, as we mentioned earlier, of malt, which includes those what we call Peyer's patches, talked about early in the lecture previously. Okay, finally, get to talk about the very end of the tract, your large intestine, diameter of about 6 centimeters, so it's quite a bit wider, and that's where its name comes from. And then your small intestine, it's only about 5 to 6 feet in length, so it's pretty long still, but not your 10 feet that we just learned about. The small intestine was. Function of it is designed for the absorption of water and just kind of the finishing touches of digestion. It consists of a series of pouches caused by gatherings of smooth muscle on the muscularis layer at regular densities, which create these kind of pockets, which we call haustra. Each of these little, I guess called pockets, is a haustra. What we do, it's actually really cool. We digest in each haustra, and then we pass it on, turn and pass, turn and pass. So that's called haustra churning, and that's kind of the very last steps of digestion that we do in our body. Okay. Those are formed by the smooth muscle rings of the muscularis layer. And we also have the longitudinal muscles, thickened bands. These are 3 conspicuous bands we can see running here and here across and down, which we call Tinei coli. Tinei coli run most of the length of the large intestine, and sporadically found associated with those are little pieces of fat that we call omental or fatty appendices. And two main divisions make up your large intestine: the cecum, which is the first segment, actually kind of a really dumb, and I say that because it's a dead end. It's only about 5 to 8 centimeters. It's described as a blind pouch located in the lower right quadrant of the abdomen, but this is where that ileocecal sphincter is found, known as the ileocecal because it's between the ileum and the cecum. It's the name. So this is a folded mucous membrane, regulates the movement of chyme from the small intestine to the large intestine. In other animals like cows, they have a much more pronounced cecum than we do. As far as what I want to talk about associated with it is your appendix, or vermiform appendix as it's labeled here. That's what it's attached to. And as we know, we learned earlier in the semester, it functions immunity. It has a little special mesentery called the mesoappendix that helps hold it in place. The rest of the large intestine is the colon, and you can actually break it down into several parts. The first of which is the ascending portion. It's known as the ascending because it runs up, food that is, there I said it, chyme, has to run upwards along the right side of our abdomen. So this is a vertical position on the right side of the abdomen, ascends to the inferior surface of the liver, then it angles and turns abruptly, so it takes like a 90-degree turn at what we call the right colic or hepatic flexure. And from there, it travels across the abdomen. Up top here is the transverse colon. From across the abdomen above the small intestine, occurs beneath the inferior end of the spleen on the left side at what we call the left colic or splenic flexure. Then we have the descending colon alongside the left side of the abdomen. And then we take another right turn back to the middle. This segment that comes back to the middle is your sigmoid colon. And that just positions us in the center of the body, where we can then run straight down and out by way of the rectum, which is the last 7 or 8 inches of the intestinal tube. The very last inch or so is the anal canal, which is shown here. We've opened it up. Basically, what's zoomed in is just this segment of the picture. And the opening for which the food, actually I'll call it feces at this point, passes out of us is through the anus, and the opening is the anus. Guarding that anus and preventing us from going to the bathroom when it's not a good time are 2 sphincters, an internal and an external. Now, internal begins with the letters IN, so does the word involuntary. I always tell students, remember it that way. It's super simple. The internal anal sphincter is made up of smooth muscle, which we have no conscious awareness and control of. And the external is what we have a voluntary control of, which is what we can use to hold it when it's not a good time to go. And when it is a good time to go, we relax it, and that's what allows us to push the feces out through the anus, along with like contraction of your ab muscles and some other muscles to help push it out. I included pictures at the bottom here showing you the 4 layers of the large intestine. There's not really a whole lot going on with it. There are little depressions, kind of like what we saw with the stomach. There's glands and cells, but really at this point are just kind of finalizing things as far as digestion goes. Mostly we're absorbing water. Something cool about our large intestine, there's a lot of bacteria in there that actually help us with digestion. They like to break down carbohydrates that are still in our chyme at this point. But unfortunately, in doing so, they release methane, which is a very potent gas, which is where your toots come from. So if you wondered why certain foods, because they probably have a lot of carbohydrates that those bacteria love. All right, that wraps us up with Unit 7. Have a good one, guys.